Hi everyone, in this video I'll be going over Apply Your Learning question number 1 from the Gas Laws unit. Question number 1 asks, a sample of chlorine gas initially at 40 degrees Celsius was compressed with a constant pressure from an initial volume of 80 milliliters to a volume of 25 milliliters. What is the final temperature of the sample? When solving gas law problems, I find it easiest to mark the values in the problem with their appropriate variables as I'm reading through it so that you can decide which equation is the most appropriate for the situation. So looking back at the problem, we see that the sample of chlorine gas is initially at 40 degrees Celsius. So we know that that can be labeled as T1, or the initial temperature. This sample of gas was compressed with a constant pressure from an initial volume of 80 milliliters, so we can call that V1, to a volume of 25 milliliters, or V2. And they're asking what the final temperature of the sample is, so that would be T2. The reason why I'm not labeling the pressure is because it's constant from start to finish. This means that it's not going to affect our gas in this situation, and so we can leave it out of our problem solving. So looking at our available variables, we have V2, T1, V1, and T2. And when we look at our available equations, we can see that the best fit for these variables would be Charles's law, which relates volume and temperature. Charles's law states that temperature and volume are directly proportional. In other words, as the temperature increases, as long as nothing else is changing, the volume will also increase. So we can write it out here. And notice that we have already labeled which value goes with which variable, so we can fill in the blanks as we go. We already know that V1 is 80 milliliters. T1 is 40 degrees Celsius. V2 is 25 milliliters, and T2 is our unknown, so we can just call it T2. And notice that the units don't really matter too much as long as they're the same from the left side of the equal sign to the right side of the equal sign. So as long as volume stays in milliliters from start to finish, and temperature stays as Celsius from start to finish, the units are not very important. They could be liters or Kelvin, as long as they stay consistent from start to finish of the equation. So going from here, we can solve this just like we would any other algebraic equation. I'm going to cross multiply my values. So 40 times 25 equals 80 times T2. On the left side of the equation, we have 1,000 equals 80 T2. We can divide both sides by 80, and that cancels out, and we find that T2 is equal to 12.5, and we keep the same unit as before, so we know that it's 12.5 degrees Celsius, and that's the answer to question number 1.